Hey everybody, it's Norm from Tested, and today I'm going to be diving deep into the new Formlabs Form 4. I've been testing this review unit for a couple weeks now. It's the newest generation of resin printers from Formlabs, and many things have changed. So we've used the Form 1, 2, 3, 3 Plus in the past. It's been a couple years since the 3 and 3 Plus came out, and if you follow 3D printing at all, whether it's FDM printing or resin printing, you know the marketplace has really exploded with printers. What's available for hobbyists, consumers, enthusiasts, and even professionals in the world of resin printing. And I think the Form 4 takes into account what technologies are available and implements a whole new printing engine in their own way. So let's dive deep into the anatomy of this machine and what makes it so different from past Formlabs printers. So first, a quick primer on how resin printing works today. You may be familiar with FDM-style filament printers, in which a spool of filament is melted down, and layer by layer, a 3D model emerges from a build plate that you slice in software ahead of time. Resin printing is kind of the same in that you're still taking a digital 3D model, slicing it into many hundreds or thousands of layers, and then generating a physical object from that. But as opposed to melting plastic, you're turning liquid resin into a solid object by curing it one layer at a time. So the important aspects for resin printers is, one, how that resin is cured, the technology that's used to cure each layer, and how fast each layer can be cured. So in the world of resin printers, there have been laser-based curing systems, there's DLP projector-based curing systems, and also very popular LCD-based mSLA resin printers, which are all over the market and which we've also tested and reviewed here on the channel. Formlabs, in their past printers, really invested in the laser-based design. And so from the Form 1 to the Form 3 Plus, they used a laser-based system to cure each resin layer, and they had what they called this LPU that was on the bottom of the machine, a mechanical system that would move along the x-axis and cure those prints one layer at a time. Now, it was an accurate system. The lasers get pretty fine, but it was also a pretty time-intensive system. So, depending on how complex your object is and how much of the build area you're actually printing on, that laser would have to move all the way across layer by layer. mSLA-based resin printers that use an LCD screen and a high-powered UV light could cure entire layers all at once. And so maybe it's no surprise that the Form 4 is now shifted over to an LCD-based curing system. So let's pop open the hood and take a look at how this works. You can see immediately that the build volume is a little bit different. The build plate size is now a rectangle, which matches this LCD curing screen that's at the base layer. Previously, the Form 3 had this square aspect ratio build plate, and the Form 4, it's 5 inches by 8 inches. That, like other mSLA style resin printers, is rectangular because of the LCD that's creating this masking layer for each layer that's being cured. There's also, like you have in past form systems, familiar easy latch Z-axis here. So one of the great things I've loved about the Formlabs printers is how you don't have to do any bed leveling. You don't have to do any plate leveling. You're simply putting the build plate on here, latching it in, and it's been pre-calibrated out of the factory to get that first layer perfectly right. Other things they've inherited from the other Formlabs, past Formlabs printers is a heated build area. So in the Form 3, you had actually a whole heated build volume that would heat up and make sure the resin was at a good temperature, an optimal temperature for curing. Here, there's a heating element on the LCD, around the LCD panel itself, that makes sure your tank, your vat here, is heating the resin to the right temperature, at least the point where that resin touches that the bottom of the film. Now the tanks also have changed. So in the past, here is an example of a Formlabs Form 3 and 3 Plus resin tank. This is a consumable, so it's something that over time you have to replace. But here's a clean one, and you pour the resin, or the resin gets poured or dispensed inside this vat. Something that was unique to the Formlabs print tanks is that it also had a mixer that you place in here. And the system is a mechanical mixer that you install. And then when you put this inside the Form 3, magnets on the bottom actually drag that mixer across, and it both scrapes the top of, or the build plate on that first layer to make sure there's no debris, as well as does a mix on the resin to make sure it's at the right viscosity and it's actually in a good formulation for printing. You can also see there's a way that they measure the resin levels inside the tank as well. So this proprietary design was something that if you operated a Form 3 or 3 Plus, you would have a couple of these, one for each type of resin. You'd have one for your clear resins, one for your Tough 2000, one for your gray. And unlike consumer printers, you're not pouring it out and cleaning it and putting new resin in it. You're kind of dedicating each tank to that resin. The Form 4 refines that resin tank idea a little bit further. So here is the Form 4's resin tank, which is a lot more capacity, and it has a lid here so you can store it. And you can already tell the film is a lot bigger to make sure it covers all that area that the LCD can cure through. There are new things like volume indicators, so you know exactly approximately how many milliliters you have, and as opposed to a mechanical system, a floating indicator for telling the system how much resin is left, it's using an ultrasonic system to measure the height of that resin, similar to what they had in the Form 3L. That's now been inherited in the Form 4. If I placed on here, it's not like 4 screws that you screw on the side to lock in place. You actually have 2 latches on the side that you just snap in, and it will then, as you heard in the sound, it will register that tank to whatever your next print's gonna be. Now, it still also has a mixing element, and this is something that you can clean and use between your different tanks, but this is a much stronger and more robust mixer than what you had previously in the 3 and the 3 Plus. And it doesn't move with these magnets on the bottom. It's now moving by this mechanical arm that you attach it to. And so you plug that mixer in place, you snap it in. That's a super strong connection. It's not going to detach like the previous magnetically attached ones, and that will slide back and forth every layer to make sure the resin is properly mixed, and it'll still do a top scrape as well before your first layer on the build plate. So at this point, I'd love to fill this tank up with some resin, start a test print, and show you how we get a print started on the Form 4. I never get tired of watching a resin printer at work. It really feels like a replicator from Star Trek, something from the future. And you can already see how fast these layers are curing, the speed of that mechanical wiper. I mean, this print has another hour or so to go. We're a little past halfway through now. So while we're waiting for this to finish up, I want to dive deeper into what it took to make the Form 4, design it, and transition the Formlabs series of printers from the previous LPU-based system to this now LCD-based system. And I was actually invited over to visit Formlabs Research Lab in Boston to learn more about the Form 4. Let's head over there now. Cole, so great to see you.
Nice to see you as well.
It's been super exciting for you guys working on this project for so long and to finally share it with the world.
Absolutely.
But I'd love to go back to where you guys started with Form 4. Obviously, very different type of printer.
Yeah.
And is this one of the early prototypes?
This is one of the early prototypes. We had actually one round before this that was even more kind of proof of concept, big 80-20 frames that were, just slap different subsystems on and see how they work, see how they function together. This was our first kind of put all the subsystems in roughly where we think they'll go on a product. And as we look down the line, it's not too far off. Obviously, we involve industrial designers later on to make it more productized, but this was the workhorse of testing out our new low force display print engine, the early stages of that, and making sure it was going to hit everything we wanted in print speed, reliability, and generally make a great printer. Everything externally on this printer looks extremely similar to a Form 3. As soon as you take these shells off and get under the hood, it looks very different. And the core optical technology has totally shifted from a laser-based system, and on the Form 3, our LFS system with a moving X stage and a flexible film tank that stage sort of pushes up on and is kind of squeezing across per layer. This is totally different. We now have super high-powered backlight unit underneath a liquid crystal display in our LPU. And so instead of rastering every layer with a laser, we're now area exposing the whole layer.
Right.
Huge benefits in print speed, but also a more reliable system. We now have no moving parts in that optical stack, in that sort of printing engine, which has huge benefits as well.
Yeah, you're moving a whole carriage, the LPU,
exactly,
across X-axis, but you're blasting a whole, all that UV light at once.
Exactly.
In terms of choosing a UV light, choosing an LCD panel, things that mSLA printers have introduced to the market before.
Yeah.
What were the priorities for you guys, and what makes this a little different than those printers?
Yeah, good question. We have an extensive existing materials portfolio that we really wanted to leverage, and so that 405 nanometer light is something that we ended up sort of anchoring on. So we picked that for our LED wavelength, and then we packed that BLU with 60 of those LEDs, so we have super high-powered light. One thing we wanted to really do is get a really uniform, power uniformity across that print plane, and so ton of really intentional design into that backlight unit to improve upon existing kind of other lens arrays you might see on the market. This is a hex pack grid for super. We can maybe pick that up.
Take a look. Yeah,
hex packed
right?
bug eye lens array here. These are aspherical lenses that are packed in to fit all 60. We have lenses on the LED itself, and then this lens array, and all that needs to be really tightly aligned to each other to give you super collimated light coming out of this backlight unit. Okay. And what that does is makes that extremely uniform and kind of predictable at the print plane.
It's like a honeycomb for a studio light or something.
Exactly, and there actually is a honeycomb light baffle underneath this lens array that does an initial kind of grabbing of all that light out of the LED, and then we go up through the lens. Big axial fan on the back here to keep this thing cool. There's a ton of power coming out of these LEDs. This whole metal thing is basically a big heat sink, keeping all this cool. First thing is kind of a ton of optical power to enable you to print quickly, but not just kind of dumping that anywhere. We want that to be really intentionally designed light, so you get really great consistent print results. And that helps you avoid surface artifacts on prints where you kind of see the lenses, which you can find in other mSLA printers.
That's not something I realized. The gating factor I always thought was, a manufacturer choosing maybe the LCD, right? The pixel size.
Yeah.
But not many people think about how important.
What's behind that LCD
of that light?
Exactly. What's behind it matters a lot, and we can move over to our light processing unit here, which contains our liquid crystal display.
Okay.
And what we have here is. Looks relatively different from any other sort of LCD replacement that you would find on an mSLA printer. That's where you see that sort of design for reliability again. Part of reliability is keeping the machine up and printing quickly again when things break. It happens in hardware, it happens in tools, and so we want to make this super easy to replace. So you have a recognizable HDMI connector there, easy for a user to plug a cable in and out of. These are our heaters. Potted in this big beefy frame is the LCD, and this is a screen that we did a ton of work to customize and basically select exactly what we wanted in terms of that pixel size, pixel shape. We landed on, this is a 50 micron pixel, it's a 4K screen. And what we found in our testing is there's actually pretty massive trade-offs between resolution, which is kind of a spec that lots of people chase and is,
of course. You see it on the printers all the time.
You see it on printers, on phones, on TVs, right? Yeah, people want more Ks in their screens, but what you get with that is actually reduced optical efficiency. So there is kind of a fixed area of electronics in the LCD, and then there's open space between those where the light can come through.
Yep.
And the electronics actually don't get a whole lot smaller as the pixels get smaller.
The screen door has to stay that size.
Exactly. And so basically, you're going to lose print speed at higher resolution screens. So
because less light is able to actually go through.
Exactly.
That screen is blocking the actual photons.
Exactly. Okay. Yeah. And so at 50 microns, we think we have amazingly detailed prints. We're not getting kind of stepped voxelization on surfaces with some of our materials like Precision Model. They just are beautifully smooth, layer line free prints, which I think is really amazing. So we really tried to nail that sort of best of all worlds with our LCD selection. And the other thing we did intentionally here is make an LCD that's going to last a really long time. So this thing can print for basically 1 million layers in a bunch of our resins. That I think is sort of unheard of for an mSLA printer in terms of LCD lifetime.
Okay, and I got to ask about this texture on top
for
here,
sure.
then, because that's different than the other just bare LCD surfaces.
Yep.
Maybe with a clear coating on top.
Yep. Yeah, this is sort of the main innovation in our LFD tech, and this is called our release film. And this is sort of an amazing simplification of a bunch of crazy mechanical prototypes that we had prior to this stage of Form 4 development. And this is basically a highly engineered film that's designed to allow airflow under the tank. So we have a flexible film tank. If you think about taking sort of two flat plates and trying to yank them apart, especially with liquid in between, it can be very high force.
Right.
And what this is doing is helping sort of defeat that vacuum, basically. So we have a tank film that now can tent freely and allow it to peel off of the part at much lower force. And there's kind of a multivariable or a two-sided benefit there. One is print speed. We can peel faster at a given peel force, but we can also reduce overall peel forces at a given speed. And so that goes directly to the supports required on the part. So you can print with fewer supports or smaller supports, easier to remove. So it also just makes that peel process a lot more repeatable and predictable so that we can tune for print settings that will work every time.
I think a lot of people think about the contact point between the exposed print, right, the cured resin, and the top of the bottom of the tank as the most important part to release. But you're talking about
there's a whole other interface.
Opposite side that also can't create any suction. Because you need your bottom of the tank, you need that whole layer to be flexible as possible.
Yep.
Yeah, and that was kind of one of the innovations of the 3 and 3 Plus, the tanks there. Right?
Yeah.
Those were 2 layers even, is that right?
Yeah, and the moving stage actually pushes that film up slightly. So what you end up doing on Form 3 is pushing up to the layer height only in a narrow region, and that moves across. So that's our LFS system and achieves the same low forces just in a different mechanical way.
You're only achieving that contact throughout.
Exactly.
Because your LP, you had the time with that one moving across that x-axis. You could release as you were printing. Almost. Here, you have to kind of release all at once because you're exposing all at once. But you also then need to counter and factor in that surface area.
Exactly. So the beauty of this film is it gets us same low forces at super high print speeds because we're full area exposure with the LFD system.
One of the things I love about your printers is just how easy a plate is to install. And there's no leveling that has happened. What allows for that?
We've got a cool mechanism that we can actually see on this middle one here. And this is called our parallelism adjustment mechanism. And there's a routine on the UI that user can do, but this comes pre-calibrated from the factory. And this is sort of a big flexure rotating piece of hardware with only 2 screws over here to loosen, and then you can precisely align the build platform to the LCD, to the LPU totally flat to each other. That's helpful if you want to fine-tune a given build platform to a printer. You can get better early layer results by matching those up. But also if you replace an LPU If you're seeing print results that you think are odd and you want to try to fine tune things, this is totally user adjustable, and there's a routine on the UI to walk you through. And one of my favorite parts is actually on the back of the printer. We store the hex keys required for
all the tuning,
for any removing shells or that parallelism adjustment. So,
was there any consideration for allowing the plate to even mount in an angle to trip off any resin? I've seen some printers do that.
Yeah, it's tough to pack that sort of mechanism into this space, but we're actually exploring sort of simple add-ons that are actually user printable. For example, a clip on the side of your tank to just kind of pop the tank onto, let things drain, and then remove. Often we just take the route of, hey, give it 5 minutes, let it drip, and things typically drain.
Yeah. What's the max capacity for a tank to operate safely?
It's a good question. The maximum capacity, we can drain a full cartridge into the tank, so it can hold a liter.
Okay.
I think it can hold a liter with the build platform down.
Oh, wow.
But if the build platform was down and you started moving the mixer back and forth, that would probably spill. And we can protect against that behavior. That would be sort of a worst case scenario. I think about 300 milliliters is where we like to operate, somewhere in that range.
I saw like a 500 milliliter, and just so you know.
Exactly.
I'm always thinking about that because I'm slicing my parts. I haven't hollowed it out. I'm like, this is a 600 milliliter part. I need to know. I don't want to have it pause middle of a print and get a line in there.
Totally. And that's where the load cell actually comes in. If you have your printer connected to a dashboard or even in preform online, you can actually see, hey, I've got this much resin remaining in my cartridge. And then we'll warn you in preprint, hey, you want to run a 600 milliliter job. This cartridge has 200 milliliters in it. You might want to swap it now before you start, so you don't run into that mid-print pause line issue.
Is the slicer working any differently and considering things any differently, knowing the type of the system versus a 3D Plus?
Good question. It's quite similar. It'll look very, very similar to what our users are used to. The whole user interface is the same as Form 3. There are some small tweaks. Of course, we tune our materials differently for this printer. The mechanics are now different. So some of the kind of preprint warnings and smart detection around minima and cups will look a little bit different just because we're trying to guarantee good prints. But all very, very similar. I think people who are existing users of a Form 3 who buy a Form 4 and plug it in and start using it will be off to the races. It's quite similar.
Yeah, how do you think of the company? Do you think of yourself as a engineering company making printers? Are you a material science company? Are you guys software and services company because you have all this?
I think it's 1/3 software, 1/3 hardware, 1/3 materials. Like we really bring all of those things together because what our customers want from us, what a professional 3D printer user wants, they don't want a printer, they want the part that it produces.
Yeah.
And that part is combination of how you set up that part in the software, what the printer did, and the materials that went into it. And so if you want to improve that part or improve the time it took to make that part or all these things about that part, you got to work across software, hardware, and materials.
Yeah.
And that's also what makes 3D printers like really fun for me personally to work on, because there's not many products you can work on that have this like incredibly wide range of engineering that goes that like meets in one product.
I think as a hobbyist, someone coming from that hobbyist field, it's like you get over after a couple months of like the wow factor of, wow, I can get this really cool thing, turn from digital bits to physical atoms now pretty quickly now. But then what do I do with that thing, right? Am I just building these figurines that are just going to collect dust, or like what's the practical application? And I know for your customer base, a lot of them are just, they come from the other perspective, or they have a need, and you're trying to service that even with the different type of materials. So I would love to talk about like things like silicone. Like you guys launched this late last year, but that's an incredible part. What goes in developing the resins and the process, I guess, so that an existing line of printers can manufacture something like that.
Yeah, this material is really cool. So it, I don't know how well you can tell on camera, but like this feels, and it is real silicone. There's a lot of times 3D printed materials are marketed as like silicone-like or ABS-like, but this is actually chemically silicone. And that's important to get the properties that silicone has, being very stretchy, chemically resistant, temperature resistant. So this is kind of a breakthrough in materials in 3D printing. And how do we do it? We have a materials science team that is is always got like a portfolio of new materials they're working on, and there's a mix of like improving the existing materials and trying to push the properties forward, and then exploring new chemistries and new possibilities that can get us to a totally different place.
Right.
And silicone has always been like something people have, asked us. We're constantly surveying our customers, asking them what do they want out of our products, what materials they want, and
Yeah.
silicone has always been in high demand.
Yeah, and even that you're tuning things when you're doing that chemistry, it really feels like an alchemy of like how much time you want to have in printer versus what that post-processing is like. Is something like your ceramic that you make, that's something that's okay to have. It's a very complicated material, but you're going to have a multi-stage process even after it comes after the printer, and so you're factoring all this stuff into the user experience.
Yeah. That's one of the unique things I think we can do, being like fully integrated, is to make a material like this work, we're often going back to changing how the hardware runs, changing the software, say like support structure, design, optimizing that for the materials. So it's not just like we have a new bottle of resin, throw it in the machine, and it works. If that's how you're working, you're not going to be able to push the performance as far as if you can work across all the domains of the products.
Yeah, and you guys also have a great service, like an online service, right? Like, one of the things I love about using your printers is I can monitor the progress on the website. They're internet connected. It's been hobbyist printers for a long time never were able to do that, kind of that remote monitoring, that peace of mind. If people are deploying many printers, fleet management is a big thing for you guys. I love that it's all free as well. Is that something that we can continue to expect to be as you buy the printer?
Yeah. So our perspective is anything that that's going to help you get better parts out and is going to be like a core part of the workflow. That should be part of the base package. I mean, our business. Because we also sell the consumables, we're interested in people using our printers more. So anything that's going to make people more successful with them and get them to use it more, we want to provide that and don't need to restrict access to that. In Form 4, we're adding a big new thing to remote monitoring. There's a camera system in here. And that's for remote monitoring. But one thing I'm really excited about is you can also make these time lapses of your prints, which are they're just fun to. It never gets old seeing a thing like grow out of the resin.
Yeah. And then the slicer software, Preform. You have a team of engineers working behind the scenes, tuning profiles for printing. You want to try to make it as easy as possible. I just discovered, I didn't even know this, that you can let users tap in if they want to, configure exposure times, and they can do that, but you want it to be a one-press button to automatically print. So talk about that software development and where it's come.
Well, so that out-of-box performance, the fact that it comes with print settings, that's always been really important for us because, again, for a professional user, they don't want to spend more time there than they need to. They want to get their part and move on. But I think we've actually missed in the past, because we've been so focused on that, we've missed in the past that we can do that and we can enable people to tune things and push the performance even further. Because no matter how good a job we do on that settings development, if you have a very specific application, a specific part, you can usually fine tune it even more. You can usually dial in the accuracy or print speed or something like that. And so we, in the past, we didn't have access to that, but we're now, there's a number of things we're doing to roll out more access to the system. Print settings editing. There's going to be print settings files that you can exchange. There's also an open materials option coming as well. Because 3D printing, we have this integrated approach. We're trying to give this great end-to-end workflow, but 3D printing is too big for us to do everything for everybody ourselves. And so we need to shift a little bit of our approach to be more of a platform that that users and also other companies and products can integrate into and build on.
From a Preform perspective, do you see more features down the line, letting people do things like hollow out models or manage multiple build plate for projects? Like Like, I'm sure there's a long running list of features that customers want or that engineers might want.
There is a long list. Those things are definitely on the list. It doesn't feel like we're anywhere near done on anything we do, but certainly not software. In fact, in the long term, I don't think we're there today, but someday the hardware might, be a little bit more kind of stable and more iterative in its development. But I think the software has can't really see the end in sight of how much better it could be.
Yeah. Going back to the hardware, then design decisions you guys made 3 years ago. I've seen that the prototypes, fundamentally the core concepts are here, and it's really great to see things that the wiper is still there and how fast it works, how easy the build plate is to install, and even the way you lock in the tray. Everything seems really great. But how do you think about core engine technology? Like a backlight is backlight. You've committed to this type of lensing system. You've also committed to this type of LCD panel. But if in the future you find, oh man, there is another LCD that does meet our needs, is there an upgrade path potential? Is this as a unit designed with that in mind?
Yes. So we have over each of the major printer platforms, we've had various hardware improvements, like within the life cycle, either new tanks or new improved optics, and some of those we've been able to kind of deploy in the field to existing users, and some have required new hardware that you need to buy. But we'd like as much of it to be kind of field upgradable as possible. So in this case, both the LPU and the BLU, the light processing unit, the backlight unit, they're both easily user replaceable, a few screws, an electrical connector. So we certainly have in mind future upgradability there.
Awesome. Well, that's great to hear. Max, again, it's been amazing to watch the journey of Formlabs over the past 12 years. And both from the machines and the resins and what people are doing with them, and watch the whole industry grow. So it's amazing. Thank you so much again for inviting me out here.
Yeah. Thanks for coming. This was fun.
Thank you. Okay, so I'm back from the Formlabs headquarters in Boston, and I've had more time to test the Form 4, so let's talk about my experience and the performance of this printer, comparing it mostly with the Form 3 Plus, and in the future I'll be doing more deep dives and comparing it to hobbyist class printers, which are getting better by the day, but are kind of a different product category, product class, especially in terms of pricing, and we'll definitely talk about pricing. But I want to start off by talking about the two big changes that going from the LPU, the light processing unit, to the LCD base curing system brings. And first and foremost, it's about speed. So when we talk about the print speed of a printer like this, you have to factor in basically the print time per layer is the metric that we're looking at most. You're looking at a bunch of stats for new printers out there, and they may list, for example, the print height per hour, millimeters per hour, inches per hour, but all that is going to be determined by, for example, how many layers that print might have. So in my testing, I did 100 micron thicknesses and 50 micron thicknesses. Full disclosure, I'm using beta firmware and beta versions of the Preform Slicer software, so wasn't able to tap into 25 micron layer heights just yet. Formlabs does promise that any type of setting that you could do with the Form 3 Plus, you'll be able to do with the Form 4, as well as all the variety of materials. But what I was able to find doing direct comparisons with the same settings, same number of layers, and the same materials, gray to gray, Tough 2000 to Tough 2000, the Form 4 is actually about 3 times faster. For example, printing gray resin, very standard resin. Most of my prints were using the gray resin to test at 100 microns, something that was about 1,800 layers, so 185 millimeters tall, which is basically the max height of the Form 3 Plus. On the Form 3, that print would have taken 12 hours and 20 minutes. The same model, same print, same supports on the Form 4, down to 3.5 hours. That's a difference in layer print time on average from 23 seconds per layer to 7 seconds per layer. And that 7 seconds isn't exposure time. It's 7 seconds including exposure, including the build platform lift, and including a wipe per layer that the Form 4 is doing. So that's pretty fast. If you're using clear resin, you can see exactly that exposure time. And while preform doesn't right now let you calibrate exactly or tune the exposure and lift times like some other slicers might, that here is an advanced setting that will be coming soon. The presets on the clear resin and gray resin are about the same. And on clear, it was about a difference between 21 seconds per layer on the Form 3 versus about 6.8 seconds on the Form 4. Again, including exposure, lift times, and the mechanical wipe times. 3 times as fast. Going on to a longer print, or not only a larger print, but a material that takes longer to expose. So Tough 2000 is a really solid, durable, non-warping resin that we love using. For example, in our Starfield project we did last year, all those chip parts were printed in Tough 2000. On the Form 3, going now even finer detail, 50 microns, so more layers, printed something about 3,700 layers, 185 millimeters tall on the Form 3. That took 34 hours, over a day and a half to print that model with an average layer time of 32 seconds. On the Form 4, that got cut down to 10 hours and 15 minutes with an average about 10 seconds of layer time, exposure, lift, and wipe. Not only is that a massive difference just sheer numbers wise, 34 to 10 hours, but what I've learned over the years working with resin prints and working with 3D printing in general, iteration time, workflow time, the rate at which you can cycle a print really matters. And if you're prototyping, if you're designing, you want to have a balance between how much time you're spending in your modeling software and how much time you're spending printing and iterating. If a model takes a day and a half to print out, your iteration time is slowed down dramatically. If your print time is about 10 hours, like a print like this, you can think of it as an overnight print. You're going to get a large print that you can get overnight. You can do your CAD work during the day. And then for smaller prints, if we're talking about under 1,000 layers or something that's small, you can get multiple iterations per day if prints are an hour, 2 hours, or 3 hours, like you can get here on the fast resins. Now, in terms of actual size of the prints, the Form 4 is technically bigger print volume. It's an inch taller. It's that rectangular aspect ratio, but it's not a massively big printer. There are bigger hobbyist printers out there. This example is, for example, is the largest thing I could print with supports on the printer. Height-wise, about 8 inches tall, printed at an angle, and so you're going to get a large tabletop miniature. Parts for a hand prop, mechanical parts that you might want to perfectly fit together, not large costume pieces, helmets, not that kind of thing. They do have the Form 3L, but that is using the LPU, not using the speedier LCD-based system. A large print like this anatomical model had to be separated into multiple components, but I was able to get the main chest part in one piece. On the build plate, the legs, you can see a little long, had to go slice those in half and print them separately and then join them together after the fact. But mechanically, everything fit really well. The dimensional accuracy is one of the things the Formlabs printers are known for. If you need prints that aren't going to warp, that need to marry and join together, that's one of the reasons you're paying a premium, not only for the printer, but also the resin and their whole ecosystem. Now, in terms of finishing and detail of the prints, this is a 4K LCD, and it's a 50 micron pixel size, which if you're familiar with the current crop of hobbyist printers, is on the large side. It's on a larger pixel size. Elegoo Saturn 4 that they just announced this past week has a 12K LCD. We've seen 6K and 8K LCDs, smaller than 35, smaller than 30 micron pixel sizes on those printers. And Formlabs chose this 4K panel Probably for a variety of reasons. They told me they wanted reliability on the backlight, even backlight through here on their very powerful UV light, combined with the layer height accuracy, 50 microns, 25 microns. They felt that was the right balance for their customers and their users. It's definitely not a printer made for printing tiny miniatures all day. It's a printer made for printing engineering parts, your ceramic parts, your silicone parts, all the fancy and exotic materials that you can get in this ecosystem. One place I did notice some improved detail, though, was on the actual topography of the stepping line. So looking up close to this bus model, and this is printed at 50 microns, I could actually, to my naked eye, pretty clearly make out the layer topography, each of those slices on this cheek here. And I could do that as well on the equivalent Form 3 Plus print, but putting them side by side, looking under a fine microscope, a macro lens, I could actually see the feature detail, the actual shape of the layer more clearly on the Form 4 print. A better example might be this miniature, looking at just the fine detail on the armor here. There are actually some runes modeled right into the edge of the armor, some texture on the armor, on the sword as well, and under a macro lens going side by side between a Form 3 Plus print and the Form 4 print, I did notice the Form 4 print having more crisp detail on the relief work on the surface of this character's armor. So it's an incremental improvement there. I don't think noticeable just held in normal lighting under the naked eye. You really have to look deeper in, and so it's a small improvement. And one of the things I was most curious by is what is the upgrade path or the lifespan of this printer. LCDs on resin printers are also consumables. Formlabs says this LCD they've chosen has about 1 million layers in its lifetime. So if you're talking about a large print, 100 microns, maybe 1,500 layers, you're going to get over 600, almost 700 prints on that. If you're printing every day, that's 2 years of printing on an LCD. That's not bad. I wonder in about 2 years' time, a couple years down the line, when Form 4 owners are going to swap LCDs, is there going to be an upgradable model? The connection here between the LCD and the printer, it's a standard HDMI port, so I could see also upgrades down the line for you to be able to swap out the LCD with maybe a higher resolution panel, or choose your trade-offs. And there could be more to look forward to even in this machine. Their business model isn't producing and developing a new machine every year. It's a machine that's supposed to last a whole generation with maybe software improvements, iterative upgrades. Things like the camera, for example, wasn't able during my testing. They just turned on the time-lapse mode, and the time-lapse video is neat. Lighting, the image quality isn't as great as using a DSLR and the resin lapse, for example, but the idea that you can monitor and check on your prints using the Formlabs dashboard is something I've always wanted for a while. Other things like local dimming on the backlight to prolong the lifespan of the LCD, fine-tuning your own exposure times and your lift times in the preform software. Lots of improvements I could see wanting or waiting to come on the preform end of things. Things like hollowing out your models to conserve on resin, or punching holes in models to stop the cupping of parts from blowing out parts, or better support generation. Right now, the auto support works, but doesn't take into account weight distribution. And the only time I have had a failed print part was when I was aggressively minimizing the touch point sizes to make them easier to snap off, but didn't factor in I had a heavier part of a print that wasn't supported well enough, and then it did fall into the vat, and the wiper caught it and stopped the print and notified me over email via the Formlabs dashboard. All of those things are nice to have features, and it's why Formlabs will tell you that their machines are premium, machines intended for business users. It's an expensive printer. Let's be upfront about that. The Form 3 Plus, $2,500, is still going to be sold after the Form 4 comes out, also for $2,500. And I was pretty surprised to hear that the Form 4 is going to go on sale for $4,500. It's a pretty significant price bump. When the Form 3 Plus at $2,500 was already considered an expensive printer if you compare it to $500, $700 hobbyist printers. Here we're talking about almost an 8x price difference between something like the Saturn IV with similar features like auto build plate leveling and a quick release film. So I really can't recommend the Form 4 honestly to anyone who isn't making money from their 3D printing, whether it's in manufacturing or prototyping. Even if you're a hobbyist and you have the discretionary income, you're going to get a lot more value and honestly quality in some regards if you go with a high-end hobbyist printer today, especially if it's your first printer and you're just getting into resin printing and you want to figure out whether it's for you. The Form 4, the Form 3 Plus, the Formlabs knows their audience. It's going to be businesses who want to take advantage of their resins, the Tough 2000 resins, the silicones, the ceramics. It's going to be for businesses who value reliability, stability, fleet management, and over cost. Where spending $100 for have multiple trays and premium pricing on resin isn't that big of an issue. And so they have lowered the price for the tray. They have changed the form factor for the resin, which also means as an upgrade path, going from the Form 3 or 3 Plus to the Form 4 means you're also switching out all your consumables. You can't really share those between your printers. So existing Form 3 Plus users, businesses are going to have to consider whether it's worth that whole switch over to make that capital investment. I mean, the advantages of the Formlabs ecosystem are still here. Things I loved, all these nice to haves, the quick to print, quick to monitor, reliability, and the rock solid quality of their really nice resins. It's all here. It just carries along with it that really premium pricing. And thankfully, they're not a services company. They're not charging any type of subscriptions for using the fleet management software, the remote monitoring software. They're making their money selling machines and selling the consumables. We'll be continuing to test the Form 4, using it in build projects here at Tested, and I will be doing a follow-up video more directly comparing this to the latest crop of high-end hobbyist printers, just so you know what's out there. But Formlabs has now made the switch finally to LCD-based curing systems, and it's been really interesting to chat with their engineers, their CEO, about their design approach and the things that they value and what makes their printer a little bit different from their point of view than what else is on the marketplace today. If you have questions about the Form 4, please post them in the comments below. Things you'd like to see us print, projects that you'd like to see us use this on, or how you'd like to see me compare this with other printers in the market today. Until then, I'm Norm from Tested. Thanks for watching, and I'll see you next time. Bye.